know how crazy madness is. Yeah, they'll have it on. Now you take those cards. I'm not gonna say what I made. That's why I'm upset. You didn't fix the answers. There was two partial credit a lot.
Okay.
There was two that I couldn't even do a lot of work because I just could not. I made 75. I just could not figure out the one that I could.
All right, for this one, go ahead. Again, this is going back to the review here. Ask you to find the domain range. Okay, domains are x values. You've got 3, 3, and 5, and again, you only have to list something once. If it repeats, just do it one time. Second thing they're going to ask you for is the range. That's your y values. We've got n, p, and q. And there you go. So that one's pretty straightforward. Not much to that one at all. Okay, number 2, still basically doing the domain and range. The only difference is for number 2 is that they give you a graph, and so you actually have to go back and find the order pairs. We'll do that one over here so we got a little bit more room. Let me straighten that up a little bit. There we go. Okay, and because we don't have all the grid lines, I'll have to go back and give you these points here. So for this one, this is where if you went back and found this point, this would be at -3, 1. This point would be at 0, 4. This point at 3, 0. And this point at -1, 5. Okay, and the biggest difference is when you're doing these is that the points won't be given, but you'll have the grid lines. But you're still going to do the same thing. Once you've got those points, you're going to go back and list off write the ordered pair, and still do the same thing. Your domain is going to be any of your x values that you have, and you don't necessarily have to do it in any order, just as long as you've got the x values. So you've got -3, you've got a -1, and I guess you can move left to right to get the numbers in order. We've got a 0 and then a 3. And for the range, if you go from least to greatest, oh wait, did one little mistake here. That should have been -5 right there. Range going from lowest to highest, your lowest point right here is at -5. Next point up would be at 3, 0. Your next biggest y value would be 1, and then 4. It doesn't matter. As long as you've got them listed, it doesn't really matter what kind of order you put them in. And sometimes people, just to kind of do that so that they're not jumping around all of these, it's maybe easier just to go back and write them all down. Actually list each individual order pair and then just go back through and do it that way. But yeah, the order doesn't matter. As long as you've got them listed in any order, you should be okay. Okay. And number 3, still kind of doing the same thing on this one, but this is one where they give you 4 different choices. That you've got 4 different relations, and they're going to ask you, okay, which of these relations are functions? Okay, we'll get the first two and then actually go ahead and get the setup here for the next two. Okay, and with all the different relations they give to you, it still comes back to one thing, is figure out whether these things are functions or not. Is all you're going to do is every single time is you're only looking at the x values. And as long as the x value doesn't repeat, then it's a function. So with relation 1, you've got -6, -4, 2, 6. Nothing repeats on these, so if they ask you, is this thing a function or not? Yes, it is. And you really don't care about the range because the range is just the answers you get out of it. So all you're doing is you're just looking at the domain values. So this one you've got G, M, B, and S. They're all different. That one's good. Relation 3, you've got repeated values on the 6's, and as soon as you repeat a value, that makes it a no. And then relation 4, where they're all the same, so that definitely makes it a no. And again, you really, for all these, if I ask you if it's a function or not, you don't really focus on the y values, it's only the x values that you're looking at. Okay, and then the last thing they give to you with relations and functions and domain and range is they just give you different graphs. And we'll just go back and give you some, and I'm going to leave off the ordered pairs and the grid lines just because it's easier. And they'll just ask you, okay, here's a graph. Is that a function or is it not a function? And all you have to do is draw a vertical line through it. And if you can draw a vertical line through it and hit it one time, it's a yes. If you hit it 2 more times, it's a no. Now this one I'll actually draw an XY axis here. Okay, and with ordered pairs, same thing. You just go back through, and if you can draw a vertical line, again, if you hit 2 points, then it's a no. Because you hit 1 point here, and there's the other point there. It hits both of those, so it's a no. Now, where they get a little bit tricky on some of those. Yeah, they give you some little staggered steps of stairs and that kind of thing. Biggest thing is that, and we'll line these up just so you can see it here, is that you do have these 2 points would be on top of each other. That's not a very good line, so let's try that again. There we go. But that's an open circle, which means for that one, there's actually not a point there. You can get up close to it, but not touch it. And back here, on the next ones, there's actually a small gap, so you're not hitting anything there. So that would be the only one that would be that case, but since that's an open circle, and that one's a solid circle, that one's okay, so that would be yes. If you filled that one in and made both of those solid, then it would be a no. Okay, and everything else is pretty straightforward. Just draw the vertical lines through it. If you can draw a vertical line, hit it 2 times, it's not. If you draw vertical lines and only hit it 1 time or no times, then you're okay. And they'll give you 5 or 6 different graphs and just have you play around with those. Okay, number 5 is a word problem. And we're going to cut through the fluff and stuff. Basically, they set you up some situation, some scenario, and they tell you, here's the equation that's set up for this thing of it, and then they're going to ask you, how much does, in this case, Robbie, earn if he sells 18 books? And they make it pretty clear that if it's 18 books, then B is your 18. Just plug in an 18 for B. So 41 plus 18 would be 59. Okay, and again, they give you a word problem at the top of it, talks about whatever it is. It's really all you need is the equation, and then they're going to give you one number to plug into that equation. And that's all you're going to do. And it's just a one-step function, so that's once you plug in that one number, that's it. That's all you have to do with it. Okay, number 6, they're going to ask you to state the domain and range of a continuous graph. Biggest thing on this one is, again, you're going to have to find out what 2 points they have at the beginning and basically you have to look at it 2 different ways. First time we do the domain. You need the left-hand point and you need the right-hand point. And when you find the leftmost point and the rightmost point, you only need the x values. So you almost have to look at this problem 2 different ways. So for the left-hand endpoint, that would be this point. If we go back and get this, this would be at -4, -2. The right-hand endpoint, this one's going to be at 5, 3. Now, here's what we'll do on this one. Actually, we're going to kind of cheat just a little bit. If you've got the open circles, like this one is, that means you're going to use parentheses. Where you have the solid circles, you actually want to go back on this part of it and make those square brackets. Because anytime you use this ordered pair that's here with a solid circle, you're going to have to use square brackets around those 2 numbers. Okay, so you're going left to right, and you're only going to use x values. So tell me the left-hand point that's on the graph. That's this point's at -4, -2. So you're going to give in -4. Your right-hand endpoint's at 5. That one's an open circle, so you use a parentheses on that one. Okay, when we do the range, now you're going not left and right, now you're going high point and low point. Actually, technically, reverse that. Should be going low point to high point. And again, when you're doing this one, because it's the range, it's only the y values. Okay, so you're going to find the lowest point. Now, depending on the graphs, and again, they're all going to be a little bit different. I know we looked at one time where it was a parabola shape, where it was like this. But for this one, your lowest point on the graph is still this point right here that's at -4, -2. And since that's the lowest point, you're going to start at -2. Your highest point is back up here at 5, 3. So for that one, we're going to use the 3 for the y value. And because it was an open circle, you would close that off with a parentheses. So no matter what graph you get, just go back and look at the left-hand point and the right-hand point for your domain, and for your range, it's the low point and then the high point, and just tell me which values you're looking at, x's for the domain and then the y's for the range. All right, so number 7, it gives you a function to evaluate. In this case, it's a rational function, and they'll give you one value to plug in. In this case, we're going to plug in 6. And again, everywhere you have an x over here, you're going to take out the x and put 6 in its place. So you'd have 6 minus 8. On the bottom, you've got 3 times 6 plus 6. And for that part of it, again, you don't worry about the left-hand side, because that left-hand side is just the setup to tell you that everywhere you have an x, you're going to place it with 6, and then you'll do the same thing over here for those two parts. Okay, and then just working out, 6 minus 8 is negative 2. 3 times 6 is 18. Plus 6 would be 24. And then simplifying the negative 2 over 24, you divide them both by 2. So final answer for that one would be negative 1 over 12. Okay, and one thing they did say on those rational functions is that if you get an answer that undefined is a possibility, and that's only if you get 0 on the bottom. So if you get 0 on the bottom, then that makes it undefined. 0 on the top is okay. You just can't have 0 on the bottom. Okay, number 8. This is where they give you 4 different problems, and they ask you, is the equation linear? And it was really more of a checklist than it was anything else. And the linear part of this one is really more what makes it not linear. And there were really 3 things we're looking at. If you have x times y, that makes it not linear. If you have x or y to a power that is greater than 1, and then you cannot have x or y in the denominator. So if you get any one of those 3 things in the equation that you're looking at, then that's going to make it not be linear. Anything other than that, we're okay. Okay, so for the very first one you've got here, you've got 3 over x. As soon as you do 3 over x, you've got x in the y denominator. So it's going to be a no. For the second equation, you've got 7x equals 3 minus y. Nothing's in the denominator. Everything's to the first power, and they're not multiplied together. So that one's good. Third one, you've got x times y right here. So that makes it a no. And then the last one, you've got y to the 5th power. So that'll make it a no. So as much as they talk about what it is linear, it's more of you cross off what makes it not linear and then just see if you have any of those other options left over. Now, and if you have extra, I know there's some problems we've done before where they would have multiple x's and multiple y's. You know, if you had 3x plus, 3y plus 3 plus 7, that's okay. As long as you can have multiple x's and multiple y's, it's still this list over here is that if you don't have any of these things, then you're okay. So you can have extra x's and extra y's and still be okay when you're going through those. Okay, and then the next, I think 3 problems. They're going to ask you to find the union and intersection. Let's just scoot this one down a little bit. Because I think we'll keep doing that one direction on the next 2 or 3 problems here. Okay, so for number 9, we'll go with M is -2, -1, 4, 6, 8. And L is -2, -1, 2, 5, 7. Okay, and the union. This was where you go back and just list anything at all that shows up. So any number that shows up, that's going to be the union. So we've got -2, -1, we've got 2, 4, 5, 6, 7, 8. And again, if something shows up twice, like we did with the first couple of numbers, you don't have to list those twice. Okay, and for intersection, that's the parts where you want to have everything that's in both of them. So you've got a -2 here, a -1 here, and then everything else is different. So for the intersection, it would just be -2 and -1. All right, number 10. Same setup. They still want union and intersection. This time, just instead of it being numbers, it's in letter form. Oh, sorry. Wrong letters. This one we're doing J and I. Okay, and again, if you're going union, that's anything and all that shows up. So we've got a B and K and J, and then a D and H and J. So we've got B, K, D, H, and J. And again, there's no right or wrong order as long as you've got the numbers in there, or in this case the letters. As long as you've got the letters in there in any form or fashion, you're okay. Okay, and for the part they have in common, that's just the J for this one. And that would be it. Okay, and then the last 2 questions, they change gears a little bit. That you're still finding union and intersection, but this time instead of it being a certain set, this time it's more of a range of numbers, or an interval of numbers. And this is one where it's probably better to actually do a graph on these. And what we'll do for this one is we'll do one of them in blue and the other one in red. And that way you can kind of see that what we're doing, when we lay the 2 things out, the union would be anything at all that shows up on the graph, anything that's covered at all. If it's intersection, then it's only the parts that would have the red and the blue on the exact same part of the graph. Union is anything at all. All right, so for this one, we're going greater than 1. So we'll put that on the top part here. So open circle at 1 headed this way. And for the red line, we'll do a solid circle here. colors. There we go. Solid circle here headed that way. Okay, so if we go with the intersection, or sorry, got the union first because we got the U here. Again, anything at all that gets covered, well, if you check that, we've covered pretty much everything, right? We started here, so there's not any part of the graph here that's not covered for this one. So I think on these they're going to ask you to write the answer in interval notation. And for this part, you covered the entire graph. So for that one, the union, since we covered everything, that's negative infinity to infinity. Well, here you've got your red and your blue right in the middle. So for that one, now this is where you have to use your square brackets and your parentheses. You've got an open circle at the 1. So we need parentheses at the 1. We get to 8. And you bracket it off. That's number 12, right? Yeah. All right, number 12. Same thing on this one. We're going to go with C is equal to, so I'm going to go with Z, where Z is less than 3. And then D, where Z is greater than or equal to 8. Okay, so the Z less than 3, we'll do that one in red. The Z greater than 8, we'll do that one in green. Okay, so for the union, that's where you put the graph out here and see what we've covered. This one, we've got an open circle at 3. Headed that way. For the Z greater than or equal to 8, we've got a solid circle of 8 headed the other way. Okay, and so you've got this gap in the middle where we didn't do anything, so we'll kind of set up the same direction on this one. We started at negative infinity, went to 3 because that's got an open circle, we go parentheses. We've got this gap in the middle, so we're going to skip over it. We're going to put the U for the union, and then we're going to pick back up at 8. Now in that case, I already messed up that one. Because the 8's a solid circle, got to put the bracket on it. Yeah, because you didn't do anything in the middle. So there's that gap in the middle where there's no color. So if you have that gap, then you just put a U for a union. That you're going to take everything here, combine that with everything that's here. All right, an intersection. There are colors that can cross over. So that's empty set, no solution. And I think that's what it tells you in these, that give the option of the 0 and the slash through it there. Okay, and they use those interval notations with the graphs to kind of get you ready for solving equations, because we're going to the less thans and greater thans where you're having to solve these. So I think for most everything in the next little bit, it's just we're going to be solving compound inequalities. Okay, so let's go with negative 15 less than 3x minus 3, which is less than or equal to 3. All right, no words on this one. So that automatically kind of forces you to know that without the words, this one's an and statement. And when it's an and statement, most of the time, now again, you'll get some special graphs, but most of the time if it's an and statement, you're going to sandwich it between two numbers. So you're going to have a definite ending point and a definite beginning point when you get through this thing. Okay, and if it's all sandwiched together like this one is, when you solve for 3x minus 3, you would add 3, but instead of just adding it to two parts, you're going to add it to all three parts, the left and the middle and the right side. And then because you've got 3x, you're going to divide everything by 3. So when we solve it, we've got negative 4 is less than x, which is less than or equal to 2. Okay, and there's your left hand and your right hand values that you're going to go from negative 4 to 2, open circle at the 4, solid circle at the 2, and then you're going to shade everything in between those two numbers. Okay. And 14 still solving. So same directions on these. Still going to solve and graph. This time, I had the word or in there, so we know it's a little different setup. Okay, and the biggest thing is when you see or, that's a union. That anything at all that shows up out of either one of the two graphs, that's our answer. So this is one where you almost have to kind of put two graphs on one line and just see what you get. Okay, but before we do that, you've got to solve the two equations. So for this one, you're going to divide both sides by negative 4. All right, hopefully your radar is going off because we're dividing both sides by negative. You got to flip that inequality sign. So now this thing is going to be greater than or equal to v negative 6 divided by negative 4. Negative 16 divided by negative 4, it's a positive 4. Okay, for this one, we're going to add 6. We've got 2v is less than negative 2. Now, in this case, when you divide this side, you're dividing by a positive 2. So even though that number is negative, that doesn't flip it because you divided by a positive 2. So you don't have to flip that sign. So we've got v is greater than or equal to 4, or v is less than negative 1. And when it's union, it's a little bit easier of an answer because you just take those 2 points you've got, put it on the graph, and then just see what you get. So we'll do this one in green. So we've got a solid circle at 4. That way. This one's already in red, so we'll leave it red. Well, try it again. We've got an open circle at negative 1. Hit it that way. Okay, and this one we're going to go ahead and do one more part to the answer on this one. There's the graph. There's the solve. And they're probably also going to ask for interval notations somewhere along the way. In interval notations, we're just going to take the answers you've got on the graph and do the same thing here. So this one went from negative infinity to negative 1. Open circle, so we'll do parentheses. This one we had a solid circle at 4, going to infinity. Mm-hmm. Okay, one more, and this one will be a little bit of a trick question. Let's go with 3w minus 6 less than or equal to negative 24. And then 4w minus 2 is, oops, sorry, wrong direction here. Should be less than or equal to negative 10. Okay, and again, with the OR, that just basically means that we're doing union, so anything at all that shows up on the graph, that's what we're looking for. Okay, so on the left-hand side, we're going to add 6, and then we're going to divide by 3. So we have w is less than or equal to negative 6. Okay, for the right-hand side of the equation, where this time we're going to add 2. And then we're going to divide by 4. Okay, so if we solve those two, we've got w is less than or equal to 6, or w is less than or equal to 2. And again, we'll go ahead and do all three. There's the solving part. We're going to do the inequalities, or do the graph of it. And then after we do the graph, we'll do the interval notation. Okay, so we've got w is less than or equal to negative 6. That's a solid circle. Hit the left. We've got w less than or equal to 2, which is a solid circle headed left. Okay, this one a little bit different because this was an OR. Most of the time when we do the ORs, they're flipped out. In this case, they happen to be going at the same direction, which means you're just going to be rowing in a circle. But when you finish it up, you're still looking for what you covered. And again, anything at all you've covered is good. So the red line went over the top of the green line. So since that happened, since this kind of covered everything, we're just going to start with negative 2 and go down to negative infinity. So they asked for the answer in interval notation. Well, from negative infinity, negative 2 is as far as we're going to go. So the negative 2 covers up the 6. So in that case, all we need is just the negative 2 there. If it overlaps, you want the one that covers the most if it's an OR statement. Now, if that had been an AND statement, if they'd asked for the intersection, you want what would have been covered on the red and the green. So if that had been an AND statement, you would have gone from negative infinity. The green line stops here, and the red line kept going, so the part where they both would have stopped together would have been at negative 6. Oh, because this one was the OR statement, correct? Okay, so if it's OR, you want anything at all that's on the graph. Doesn't matter what color it is. So we went from negative infinity. The green line stopped here, but the red line kept going. So in that case, you would cover everything from negative infinity up to negative 2. If they say they want the intersection or an AND statement, that's where you got to have both the red and the green. So the red and the green stops here because you've got green to this point, From here on, it's just red. And if you want the and or the intersection, you got to have both red and green, so they stop right here at the -6. So that's one where they could kind of do that as a trick question either way. Kind of look at the overlap at the intersection there. So, or you take anything, if it's and, it's got to be the same, it's got to be both colors. And the part where you had the both colors was right here from negative infinity up to -6. This is more of a what if. So what if we had to find the intersection? Yeah, that if it's an intersection, that's the and, that's both colors. So yeah, so you'd stop at -6. So or is anything, and is the overlap. Or is anything at all, or is either color. Tell me red or green, doesn't matter. And has to be both red and green at the same time. Okay, so we get a break from graphs for just a little bit. We're going to just solve absolute value. And this is number 16. And everything else from here on out, I think, is all absolute value. We're just going to do equations, and then we'll get some inequalities. So we're going to do 5 times the absolute value of y equals 50. Okay, and the number one thing with absolute values was you have to get the absolute value by itself. So for this one, this is okay by itself. We've got to get rid of the 5. So the first thing we're going to do is we're going to divide both sides by 5. And that'll get you down to the absolute value of y equals 10. And with absolute value, that's where once you get the absolute value by itself, we said you can move 10 spaces in either direction. So 10 left or 10 right. So that's where you would split this up into 2 parts. Because you could go 10 to the left, which would be -10. Or you could go 10 to the right, which would be +10. And that's where you're going to have your 2 solutions. Okay. And if there's any one big thing I can get across to you when you're doing these, make sure you give me 2 answers. Yeah, so in big letters. Now, not every case, but in most cases, you're going to need 2 answers. Most of them, it's going to be 2. Now, one of the cases where you won't get 2 answers is if this was equal to 0, because there is no positive and negative 0. If it's 0, there's only 1 answer. And if it's negative, it's no solution. Yeah, that's a trick question. And I'm sure one of those is going to pop up next. If not, we'll throw one in there. All right, 17, still solving. Oh, and look what this one is. It's the absolute value of 4v minus 12 equals 0. All right, in this case, the absolute value is by itself. So this is where they would tell you to split it up into 2 parts where you've got the negative and the positive. But we just got finished saying is that there is nothing, negative 0 doesn't exist. So for that one, yeah, negative 0, positive 0, it doesn't really have a sign, so you don't have to worry about the negative 0 because it doesn't really make any sense. So from there, you're just going to solve this one equation. So you could add 12 and then divide by 4. So for that one, you get one answer at v equal 3. Again, the only two times you won't get two answers is if the absolute value equals 0, or if the absolute value equals a negative number, then that one you just get no solution. Okay, so let's go with the absolute value of 2x plus 5 equals negative 7. There you go. Don't do anything. There's no solution. There you go. Now, the catch is on that one is that you've got to get the absolute value by itself, because sometimes they'll kind of trick you that they'll start off with it being negative, where that you may have something like that where it looks like it's there, but when you get rid of this negative 10 by adding 10 to both sides, well, then you've got the absolute value of 2x plus 3 equals 6, and that's a positive number. Then you're okay. Then you go through an answer and go from there. Well, if it's absolute value by itself, once you got the absolute value by itself, if that's a negative, then you stop right there. And I'm saying the only part where sometimes they get a little bit tricky is that they'll give you one at the beginning where you've got this where it equals negative 4, but you've got this other number that's here with it. So once you get rid of this number, once you move this 10 over to here, you've got absolute value by itself and equals a positive 6. Then you're okay. Then you're going to go ahead through and solve it from there. All right, so for 19. Let's go with the absolute value of 4v plus 40 equals 40. Okay, and again, before you can do anything, you've got to get rid of this positive 40. So we're going to subtract 40 from both sides. We've got absolute value of 4v equals 0. And if it equals 0, then you only got one solution, because there is no positive and negative 0. There's just 0. So 4v equals 0. Divide both sides by 4. In that case, that means that v would equal 0. Again, we don't worry about the negative 0 because that doesn't make any sense. So we still just got the one solution there. Okay, so let's go with 3 times absolute value of 2u equals negative 30. Because on this one, if you divide both sides by 3 to get the absolute value by itself, its absolute value of 2u equals negative 10. And that one, don't have to go any farther, that's just no solution. So key thing on those is you have to get the absolute value by itself. Once you get the absolute value by itself, that's where you stop and check it and see what you have. Okay, rest of the way down, we're doing inequalities. So in 21, they start you off with one where you don't have to really do much of anything at all other than just graph it. And the key thing on the inequality is you have to know what kind of sign you're looking at. That one's a less than. And when you have a less than, you have to know that this one's going to be in and statement. And with an and statement, you sandwich it between the positive and negative of those two numbers. Okay. And for those, you can basically just take the y that you have, and again, because it's going to be less than greater than 4, but at the same time, if we were to flip this sign around and make it y would be greater than negative 4. So that's where it comes sandwiched between the negative 4 and the positive 4. All right, if they ask you to solve it, that's your solving part there. If they ask you to graph it, okay, and again, if it's an and statement, which is what this one's going to be because it was less than, should be sandwiched in between positive 4 and negative 4, and then just fill in the gaps in between. Okay, so once you've got the absolute value by itself, you're always going to sandwich between this positive number and then turn around and make that number negative, and you're going to sandwich it between those two numbers. Don't think they're going to ask for interval notation. If they did ask for interval notation, we'll go ahead and do it anyway. It would be from negative 4 up to positive 4. Okay, 22, same thing. Still solving the inequality, just different numbers. This time we've got 6x is greater than 60. So just like you did with the equations, before you do anything, you've got to get the absolute value by itself. And when we do that, now we've got an absolute value of x is greater than or equal to 10. Okay, and once you've got the absolute value by itself, it all keys on what that sign is. In this case, that one is greater. You have to remember that it's greater, so it's actually going to be an or statement here. So it's going to be x greater than 10 because we're just going to pull that number straight out. And we're still going to keep it between 10 and negative 10. But with the or statement, you actually have to break it up as two separate inequalities. And because we made this negative 10, you got to flip that inequality around and make it go less than. Okay, an and statement should sandwich it between two numbers. If it's an or statement, you pick your two numbers and you flip it out so it looks like or is on a boat. Only difference on this one is these are both solid circles. So we'll have a solid circle at negative 10 going left. Solid circle at positive 10 going off to the right. Okay, and again, that's the big thing, is that if it's an less than, it's an and statement, you sandwich it between the positive and negative of that number. If it's greater, it's an or statement. It should be like oars on a boat, should be flipped out of those two numbers. But it all keys on the sign that you get. Less than, it's going in between the two numbers. If it's great or, it's on the outside edges of those two numbers. Interval notation, that one would be, we go from negative infinity up to negative 10. And because it's a solid circle, we'd block it off. Go union, block off the 10, and go to infinity. bracket here, parentheses there. Because again, with infinity, it doesn't matter what it's always parentheses. I think I made that worse. Okay, so for this one, next one, still doing the inequalities. X plus 26 is less than 15. Okay, so for this one, we've got the absolute value of x is less than negative 11. Okay, now the difference with inequalities is, before if we had an equation, we stopped and we said it was no solution. This one could be no solution, or this, because the inequalities, it could be no solution or it could be infinitely many, because it just depends on how you're setting this thing up. Because if you're doing this, we said absolute value of x means the answer is always going to be positive. Is there any way a positive number is ever going to be less than negative 11? Can't be, right? So in this case, this would be no solution. Now, what would change that? If you flip that around and made it absolute value of x greater than negative 11, and we know the absolute value is always going to be positive, is a positive number greater than negative 11? All the time, right? So that would be always. So if you still get a negative number, with equations, it was always no solution. With the less thans and the greater thans, it's still a trick question, but it's either always true or basically never true, and it just depends on the situation, what you're looking at. So if absolute value is a positive number, there's no way a positive number is going to be less than a negative number. So that'd be no solution if it's less than. If it was greater than, well, positive is always greater than a negative number, so that makes that one always true. So it's a trick question. You just have to think about what your situation would be when you get there. Okay, 24 gets away from all these trick questions. And back to just some regular solving here. Let's go v minus 2. Let's just make it greater than instead of the equal to part. So v minus 2 greater than 5. Okay. The absolute value is already by itself, so now we're just worrying about what that sign is. Again, that's greater. So we've got to flip this. So when we get finished with it, it should be flipped out where you've got one arrow going off to the right, a gap in the middle, and one arrow going to the left. So we've got v minus 2 is greater than 5, or v minus 2, when you make this a negative 5, you do have to flip that inequality sign and make it go less than. Okay, so we're going to add 2. The v would be less than negative 3. This one you're also going to add 2. So v would be greater than 7. Okay, so we're going less than 3, negative 3. And we're going greater than 7. And this one does not ask for interval notation. We can do interval notation just to be on the safe side. Okay, 4 more to go. So let's go with 2x minus 14 less than 6. Okay, and first thing on this one is again, it's the absolute value is by itself. So now we're just looking at what this symbol is to tell us what we're going to do. It's less than. And if it's less than, that means it's an and statement, which means it's going to sandwich it between positive 6 and negative 6. Okay, and again, from this one, you're going to work it from the inside out. So if you had 2x minus 14, the first thing you do is you would add the 14, but this time instead of just being with 2 parts, you're going to add it to all 3 parts. So adding the 14, we get 8 less than 2x less than 20, and then go back through and divide everything by 2. Got 4 less than x less than 10. So it should be everything between 4 and 10. And again, we know that because it was an and statement, and then with the and statement, you're going to sandwich it between those 2 numbers. Okay, in interval notation, I'm going from 4 to 10. Both of those are open circles, so we go parentheses. Okay, so let's go with 6w minus 6 plus 3 less than or equal to 15. Okay, before you do anything on this one again, you've got to get the absolute value by itself, so get rid of this 3 by subtracting 3 from both sides. Okay, and once you've got the absolute value by itself, then you can look at the signs. Well, in this case, it's less than. So that's just like the last problem, which means it's an and statement, which means in this case you're going to sandwich it between negative 12 and 12. Okay, and just like with the last one, you're going to work it from the inside out. So since you've got 6w minus 6, first thing is you would add 6 to all 3 parts. And then since you've got 6 times w, go back and divide everything by 6. Okay, and that was an and statement, so again, should be sandwiched between negative 1 and 3, and this time it was solid circles. And if you need an interval notation, time, because they're solid circles, would be square brackets instead of circles. Okay, 27. They actually sneak in one more equation. So we'll do one more equation and then one more inequality. Okay, and the last equation, we've got 2 times 3v minus 6 plus 5 is equal to 35. So a little bit more work on the front half of this one to get it going. So for this part of it, first thing you want to do is get rid of this plus 5. Because again, when you see this part of it that's here, this is the part you're keeping. So that's almost, you can think about that as being one big giant X, that's what you want to keep. You've got to get rid of the times 2 and the plus 5. That's an equal sign right there. Yeah, let's make that a little better. There we go. So first thing we should do is subtract 5. We've got 2, absolute value of 3v minus 6 equals 30. And because it's 2 times this, then we'll go back and divide by 2. Okay, once you've got the absolute value by itself, that's where you want to kind of stop and check it, that this thing is equal to a positive number, so we're good. And from here, we're going to split it up into 2 parts. 3v minus 6 would equal negative 15, and then 3v minus 6 would equal positive 15. And this is right up against the bottom of the page, so we'll go to the next page and finish this thing up. Okay, so add 6 to both sides on this one. Divided by 3, we get v equal to negative 3. V equals 21, so divided by 3, we get v equals 7.